Good morning, everybody. This is a live emergency briefing as we have a sleeper tornado setup that's coming together across central Indiana into western Ohio that includes Indianapolis. This MCV was from the cluster of storms that formed across southern Nebraska, impacted Kansas City, even with a reported tornado and damage near Kansas City, and then it came through St. Louis as well. So this is a long-lived MCV, and these MCVs will act as a surface low that can enhance locally the wind shear. And you can see a little bit of spin underneath these arriving high clouds. These are the high clouds arriving with a shortwave upper level trough. It's going to be associated with this system. That's going to provide the necessary deep layer wind shear for supercell storms to organize across central Indiana and Ohio. And you can see the 5% tornado risk that has been added. That even includes a portion of Illinois just to the southeast of Champaign into Indianapolis and then eventually into western Ohio. And that little spin that you see right there is going to keep chugging off to the east, eventually arriving into central Indiana by peak heating. So once you start to get the heating of the day, there's a lot of moisture as well up here, minimal capping inversion, a little bit of lift that is provided by this arriving MCV and the upper level shortwave trough aloft. That's going to develop isolated supercell storms near central Indiana, probably developing first near the Indiana-Illinois border by about middle afternoon, probably 4 p.m. And a cluster of supercells very close to the MCV center is going to track very near Indianapolis. Short-range models show sufficient low-level wind shear for tornado potential. And usually with these MCVs, you get a little bit of a low-level jet, a pop with the low-level jet, 40 knot southwesterly winds just above some backed winds that are caused by the MCV, which basically behaves as a surface low. And you can already see an arm of thunderstorms and some rainfall here that is lifting up through into Indiana, into central Indiana from Illinois. In the wake of this band of clouds and storms, you're going to have rapid destabilization, rapid heating as well. The MCV, the actual surface low, is off to the west of this feature. It's actually not associated. This is just an arm lifting off to the northeast. A little bit of warm advection as well ahead of that MCV surface low. There are some storms that have prompted a special weather statement to the southwest of Indianapolis, but this is going to lift through, might even leave behind some remnant boundaries across central Indiana that MCV will move across, storms will interact with. Usually outflow boundaries are associated with horizontal spin, and then you move a storm over that horizontal spin and it stretches that spin into the vertical, and that's in general how you can get tornado producing storms. But I want to break down the short range models as well. Satellite imagery is always a great place to start any weather forecast. The next place to start that forecast would be the surface map. And this is a great place to look at the surface obs. These are real observations. We're trying to look at the moisture situation right now. And you can see that arm of convection that's lifting off to the northeast, and rainfall is definitely moisture advection, warm advection ahead of the MCV. And overall, you can see that the moisture situation across central Indiana is relatively bleak so far this morning with upper 50s dew points, but then just to the south where you have that warm front, that's effective warm front lifting off to the northeast. That's really what that arm of precipitation is associated with. That's going to continue lifting off to the northeast, and once that moves through, it's going to be replaced by incredible moisture. Near 70 dew points, upper 60s dew points are lifting off to the northeast behind that effective warm front lifting into central Indiana, and that's going to continue lifting off to the northeast, maybe even setting up into central Indiana. And then the MCV is just going to propagate right along that effective boundary, arriving into central Indiana by peak heating. It's going to be associated with relatively strong wind shear additionally, and that's why there is the 5% tornado probability you can see in the upper right portion of the screen, and that includes Indianapolis, basically stretches from the Illinois-Indiana border all the way off to the east. But so far, the dew points in central Indiana in the upper 50s, that's ahead of the warm front. That warm front is going to come through, and then we're going to be talking about rapid destabilization, development of supercell storms. This is the HRRR model. Let me square this up on my screen. Get rid of the standby up there too. Boom. This is the 14Z HRRR, and we go out to 21Z. And you can see quite a bit of surface heating. Basically, across southern Indiana, you have temperatures rising up to near 80. You have a belt of upper 70s. Looks like Indianapolis gets into the 70s by peak heating as well. Some cloud cover. And you do have that effective warm front, which should lift up to Indianapolis as we go through the day. Let's just jump straight to composite reflectivity since that's what we do. That's what everybody does. We have very limited attention spans these days, so we just got to jump right to the butter. And here you can see the cluster of storms that develops across central Indiana, right on the northern edge of the differential heating boundary. This storm appears anchored along that effective warm front, which basically lifts up into central Indiana, central and southern Indiana. You also get a cluster of supercells that try to develop near the Cincinnati area. You're included in that 5% tornado risk. And let me see exactly when these develop and step a little earlier. This is at 4 p.m. 4 p.m. Central Daylight Time. This is at 3 p.m. Central Daylight Time. You can see these storms developing near Indianapolis. They actually fire at about 2 p.m. So this is 2 p.m. and you can see these bubblers just along the south edge of the MCV. That's at 20Z, and the HRRR is even picking up on that subtle surface low. That's really what an MCV is. It's a mesoscale convective vortex. It's a leftover surface low from a previous complex of storms that came through Kansas City, came through St. Louis, and now it continues to move off to the east. This is at 19Z. This is at 2 p.m. Central Daylight Time. You can see the MCV there in central Indiana, and it is associated with a cluster of supercell storms, some stronger wind shear as well. Near that surface low, it even notches down, intensifies by about a millibar or so. And just ahead of this MCV, you could see how there are some southeasterly surface winds just north of the warm front, east of the MCV and effective warm front. South of that warm front, you have more southwest and northeast surface winds, southwest and northeast. But just ahead of that MCV, you get these southeasterly winds, and that enhances the low-level shear right along that belt just ahead of the surface low. Looking at the upper levels, we'll see a little shortwave trough that's associated with this as well. And it's not a little trough. It's actually a pretty potent trough with about 50 to 60 knots punching out from the Illinois-Indiana border into central Indiana, eventually into western Ohio. And that's also going to be associated with a stout low-level jet. Look at that 35-knot low-level jet. And your 0 to 1 kilometer EHIs, that blue area is where the environment is coming together for tornado potential. It migrates from central Indiana, arriving into southwestern Ohio by about 4 p.m. Central Daylight Time. Look at that around Cincinnati, 4 to 5 p.m. Central Daylight Time is when that very favorable environment for tornado potential. Skyline chilly meets MCV tornado setup. Eastern, southeastern Indiana into the southwestern portion of Ohio, maybe even northern Kentucky could get in on the action down near Louisville. Obviously, the effective warm front right along the northern edge of that greater Cape, probably right in the middle of it. I bet the effective warm front is about like that because you really need those southeasterly winds to create some non-zero wind shear favorable for tornadoes. Let's cherry pick a sounding near the Cincinnati area. Forecast sounding and hodograph. First, let's look at the hodograph, and you can see a lot of curvature here. 1 kilometer wind up near 30 knots. It might even verify a little bit stronger than that. Wouldn't be surprised if you do have a 40-knot low-level jet. Due easterly storm motion at 30 knots and immense low-level wind shear. You have about a 30-knot 0 to 1 kilometer shear vector there. So more than sufficient and a shear for tornado potential. And you even have relatively strong mid and upper level flow to evacuate hydrometeors from the updraft. Scrolling down a little bit to show you the thermodynamics, the very favorable thermodynamics with this setup, and some decent directional shear. There will be greater directional shear at the low levels here just to the east of the surface low, where you can get a southeasterly surface wind. You can see here you basically have a due southerly or south-southwest surface wind at about 10 knots. So really with a southeasterly surface wind, you're bringing your surface wind back here and even expanding your 0 to 1 kilometer shear vector a bit just to the east of the surface low. Interestingly, you do have a little bit of a dry slot coming in the mid-levels of the atmosphere. That's because this MCV has an associated strong shortwave trough with 50 to 60 knot winds, cyclonic curvature up there, and usually those westerly winds will transport a dry slot, and that is helping to carve out a lot more CAPE. Sometimes these MCVs during the summer will kind of have tropical soundings, very moist all the way up, lapse rates not as steep. But when you have a shortwave trough superimposed in there and you bring in this dry slot in the mid-levels of the atmosphere, it'll create even more instability in the mid-levels of the atmosphere. By this time, by about 5 p.m., you're going to have a cluster of supercells moving into this environment across southwestern Ohio. You can see some of those bright colors. That's surface-based instability. And then you can also see every grid point, there's a hodograph plotted, a model hodograph. This one is a straight line hodograph north of the effective warm front. Not very conducive for tornadoes, but this one a little closer to the bright colors down near Cincinnati has some curvature. This one across southern Ohio. And you can tell that the MCV has passed over southeastern Indiana. You have a more straight line hodograph. But it definitely shows that this area over southwestern Ohio by 5 p.m. is going to be the prime spot for tornado potential. It's going to start off about central Indiana, very close to the Illinois-Indiana border. That's going to propagate off to the east-southeast and bring that tornado potential down into the skyline chilly headquarters of Cincinnati. A little bit of a front that drops off to the southeast as well, but you really want to play just east of that surface low, which is going to be very close to the Ohio-Indiana border by about 5 p.m. Effective surface low, or MCV, mesoscale convective vortex. Let's go back to the composite precipitation here, forecast modeled precipitation. And you can see that this band of supercells, and even supercells behind the lead MCV, probably going to have some supercell storms as well over southeastern Indiana by this time, moving towards 6 p.m. Central Daylight Time. Still have some renegade supercells back behind. Lead supercells moving into central Ohio. See if the updraft helicity tracks pick up on this. These are miniature, kind of smaller size supercells, as you'll often see with MCVs, so you don't see these big purple tracks like you saw with the elevated hailers yesterday. But you can, in general, see where that tornado potential is going to set up. That's the 5% from the Storm Prediction Center, central Indiana into western Ohio. These are all little mesocyclone tracks kind of hinting at where those individual supercell storms might form. Still waiting on my car. It's still in the shop, but it was very much in need of some substantial fixes. Might even be in need of a new engine. A lot of parts as well. There's part shortages out there, and it looks like on this big Northern Plains push on June 12th through the 14th, I'm going to have to play the rental car game once again. This supercell composite by 4 p.m. Central Time. You can see some of these bright colors. Let's change over to the 3-kilometer NAM. Yes. Dominating bright colors out there across central Indiana. 3-kilometer NAM is going to the moon with this MCV setup. In my experience, a lot of times the RAP model does a really good job with predicting the destabilization around these MCVs. And there is a nice stout elevated mix layer that's coming in with that attendant shortwave trough. So I do think that there could be greater instability than the HRRR model is showing. And if that happens, we could even have a regional outbreak of tornadoes with this MCV setup. Look at those 40 knot 850 winds right up ahead of that surface low, ahead of the MCV by 21Z. A little bit earlier by 3 p.m. You can really see that low level jet come together. Look at that 40 knots, and it curls to a more southerly direction. It's a compact setup, but right at the upper portion of this low-level jet, that is where I'd expect there to be tornado potential, supercell storms. Look at that 40. This is the wind about 1 kilometer above the ground. You've got 40 knot 850 winds. This is where your tornado potential is going to be maximized right at this time, right on the northern fringe of the low-level jet. This is at 3 p.m. Central Daylight Time. So watch out, starting at about 1, 2, 3 p.m. Indianapolis, ahead of this MCV. These setups can be a little bit conditional. They're either going to be just some showers and thunderstorms around, or it's going to come together with a potential regional tornado outbreak. There's the 3-kilometer NAM. Let's go back to the HRRR. And the 3-kilometer NAM is stronger with the low-level jet, isn't it? Stronger, seems to have a stronger, more backed low-level jet in the northern portion of the MCV. Looks like we have storms that develop from central Indiana all the way down. Damn it, I should have chased this. Look at that. This is going to be a big-time event here, I think, folks. Probably the northern couple of supercells up here in central Indiana are going to have pretty substantial tornado potential. Right up here, those are the storms that I'd be watching. This is the rain blob that's associated with the MCV, and anywhere south of that rain blob is where the surface-based instability materializes. But the greater wind shear is going to be tucked right up against the southern edge of the MCV. If you believe the 3-kilometer NAM model, then this looks like it's going to be a pretty substantial event. And I believe it, with an MCV coupled with such a potent upper level speed max, I do believe that this is going to be a pretty substantial tornado event moving into eastern Indiana, eventually into western Ohio. Very favorable photographs being analyzed here, even more favorable than the HRRR model. Easterly storm motion at about 30, a little bit north of east. Tons of low-level wind shear available for these storms to rotate. Just look at that photograph, and that is a very textbook photograph for tornado potential. You've got strong mid and upper level winds also that are going to be evacuating the rain and the hail from the updraft. So this is very much not a sleeper setup, but I would say that this is a big-time tornado setup here. We're going to upgrade the terminology. 3-kilometer NAM picking up on that dry slot coming in the mid-levels of the atmosphere. A lot of directional shear. It's better picking up on the directional shear that I would anticipate ahead of that MCV. Moves into western Ohio, maybe even west central Ohio here by 6 p.m. Central Daylight Time, 7 p.m. Eastern. And it starts to attain more linear characteristics to the south, but still a supercellular mode moving into central Ohio. Look at those storms by the 3-kilometer NAM, 2 to 3 p.m. They initiate near the Illinois-Indiana border, just northwest of Indianapolis. 2 p.m. Central Daylight Time, PDS tornado sounding. The NAM has been overdoing some of the thermodynamic and kinematic environments within these warm sectors a little bit, but that would even suggest a strong tornado potential across central Indiana. Very steep low-level lapse rates, immense 0 to 3-kilometer cape, a lot of directional shear in the low levels of the atmosphere, stout elevated mixed layer punching into this, helping to steepen the mid-level lapse rates. I think there could be a significant tornado or two with this type of a photograph into central Indiana, just northwest of Indianapolis. Very favorable for a strong tornado or two, especially if you believe the 3-kilometer NAM, which seems realistic. That's a potent shortwave trough up here. Very potent, a ton of cyclonic curvature, nosing in Illinois, Indiana. Here's where those storms develop, just ahead of the trough axis. Wow. See if there are any differences in the strength of the upper level trough. Looks like there's quite a bit of agreement between the shape of the upper trough and the strength. Maybe a little stronger in the 3-kilometer NAM. Much stronger surface low. Gotta wonder if that MCV is going to intensify in response to the shortwave trough approaching it from the west. This is late morning. It's got 1,007 surface low over east central Illinois. 1,006. Boy, 1,006 really intensifies that surface low after about 20 Z. Bombs it out to like 1,001. 1,000. Whereas the 3-kilometer NAM has a more diffuse surface low. It doesn't have that rapid cyclogenesis that is being shown by the 3-kilometer NAM, dropping this thing down to 1,000 millibars. The wind field, of course, responds. The low-level shear, of course, will respond to that. Pumping PDS soundings all over the place. Your parameter space is much higher, even right up tight to that MCV. Look at that environment space there by about 1 p.m. 1 to 2 p.m. Central Daylight Time, southwest of Indianapolis, near Terre Haute, near the Illinois-Indiana border. Quite a favorable parameter space for even strong tornadoes out here. Look at that photograph. We talk about photographs a lot here. We're just going to continue to hammer them, and eventually you'll have them figured out. That's a large looping photograph with very strong wind fields in the low levels and aloft. You have storm relative outflow aloft. You have storm relative inflow in the lowest 3 kilometers. And you also have an intake of near streamwise vorticity with a near 90-degree angle with the low-level shear vector. That means that the storm is moving parallel to any invisible horizontal spinning tubes induced by the low-level wind shear and the low levels of that photograph. So that space really blows up as the surface low bombs out according to the 3-kilometer NAM. I'm not sure. It seems to be a bit of an outlier. There are some model discrepancies as to related to the speed that the MCV ejects. But you can see this arm of low-level wind shear and instability reaching up into central Indiana. Definitely has some potential. Let's take a look at the RAP analysis. Let's see if they upgraded. Still a 5%. That's the 13Z, obviously. Another half hour until we get that new outlook. Wonder if there's going to be a 10% area maybe painted out ahead of that MCV. It's a relatively diffuse, weaker low here now, just northeast of St. Louis. But the RAP doesn't blow up that surface low like the 3-kilometer NAM does. 3-kilometer NAM has a ton of convection that form in the vicinity of the surface low, and I think that there is some release of some release of latent heat, and you have kind of the rapid generation through the release of latent heat that causes a runaway cyclogenesis effect within the 3-kilometer NAM model. This model, the RAP model, has a more believable surface low evolution that's a little bit closer to the HRRR. See how it keeps that at about 1,008? There's your cluster of storms, though. They developed by 19Z, central Indiana, south of Indianapolis, southern Indiana, eventually moving into the Cincinnati area. And that's also where the strongest wind shear is located. This is the effective helicity. And you have about 150 to 200 0 to 1 kilometer shear. And for these little supercells, that's more than sufficient to have a tornado threat. Looks like central southern Indiana, maybe into southwestern Ohio. I don't think that I'd upgrade to 10% just because of the outlier that the 3-kilometer, there's the effective warm front with those 70s dew points being analyzed. Let's track the progression of this warm front out of southern Illinois. There's 19Z. It makes it up to Indianapolis. by 19Z. So by about 1 to 2 p.m. near Indianapolis, you're in the instability. But see that gradient, that this is the warm front. You can track it up to central Indiana. That's by 1 to 2 p.m. And any of those storms that are able to interact, especially with those southeasterly winds near this effective warm front or differential heating boundary, will have a greater threat of tornadoes. All right, everybody, I think that is it. Once this moves through, it'll get sunny, and then eventually I think that moisture could arrive, the differential heating boundary could arrive to Indianapolis, but maybe just south of Indianapolis looks even more favorable potentially for tornado potential. All depends on if that differential heating boundary is able to make it up to Indianapolis. But certainly stay tuned to those severe weather watches and warnings across the 5% area. I do think that there is a chance of even a regional tornado outbreak, possibly. Watch out, Terre Haute, Indianapolis, just to the south of Indianapolis, all the way out to Cincinnati, western Ohio. Certainly needs to stay tuned to those watches and warnings all the way into central Ohio as well. These MCV events have a tendency to produce up here in this part of the country, produce tornadoes. So definitely stay tuned. Yesterday, there was a tornado of the year, I believe, just east of Lusk, Wyoming. We were live doing a radar breakdown when that tornado warning came out, and that snapped 3 power poles into the northwest corner of Nebraska. The northwest corner of the Nebraska Panhandle is where that happened. And there's another couple of brief tornadoes that were reported down into southeastern Colorado from those 2 supercells that were moving through. And then there were some QLCS tornado reports too, one of which was relatively close to the Kansas City area last night. Thank you, everybody, for tuning in to my weather report. Stay safe. Never stop chasing.